Thanks for coming to my talk. And the song that was playing during this break, it was, somebody knows maybe? Kraftwerk, yes, the robots. And this particular version was actually played by the robots on a concert in Germany in 2015 in Stuttgart. So you heard the robots playing. And honestly, I prefer humans to play me music and robots doing the other stuff. So before I joined robotics industry a couple of years ago, I was more like a software person background. So I worked mostly in the software space for almost like 14 years in my career. And recently, I just fall in love in embedded systems. So this talk will be for my first experiences with working in a startup, in a robotics startup. So let's get started. Last year on a conference, the other conference, not this one, I met a robot on the red carpet, and it did a good job, like for a short period of time, and then this happened. Its walk apparently didn't last so long, because, well, it suffered from communication error. And I wanted to help this little robot, but the message was, hey, in case of this error, please call this number, but there wasn't any number on the error screen. So in this context, I really couldn't help much. So I moved on. This cleaning robot will not help me. But what can maybe help me? Let me introduce you to the context I was working with in this startup. It's a robotics startup. And we will see on this little video that these robots operate in highly risk environment where humans actually walk around. And there is no boundaries, so the robot needs to understand where it goes, which you can see on the right side of this video. It's how the robot sees the world. Left side is the camera. And it's quite dangerous because it needs to recognize the humans and where the wrecks, where to go. So in this context, there is a really high risk because somebody can get hurt. And when operating in this kind of environments, where humans are walking freely around, and work together with the robots, there is a huge risk that the product we are working on and building can maybe even hurt somebody, not to even go further. But there is a good news in all of that. Because when you have high-risk environments, then nobody questions the value of testing, because testing is really important. So this is the first lesson I learned when I started working within embedded systems, and yeah, I really like that fact. And also, there is another thing. Things are expensive. Things we are testing and things we are developing and the components we are buying or building in-house, they cost a lot of money. So as a tester, when you operate with this kind of things, you need to be mindful not to break stuff. Because this wheel that's not in the right place where it should be can cost, it's not like a car tire, it can cost a couple of hundreds of euros or even more. So being mindful of those type of things is important. And also, it's a startup. And in startup, you always have limited resources. So using our resources mindfully and particularly not to break them, it's very important because we know that testers do not break things. So a little bit about the product. Product itself consists of 6 main pillars, or let's call them like layers. First, you have to have some expensive sensors to perceive the world around it. Then we need to understand the world. The robot needs to understand what is this, what they are seeing. It's called semantics. So this is a lot of training on different machine models for particular use cases. In this case, industrial and warehousing. Then the robot needs to know where it is. That's what we call localization. So first, it needs to know where it is into the space to navigate to the next point, which is the next important layer, the navigation part. And then robots are not, they like to socialize with other robots. And they work together in a fleet. Because if you have one robot doing the job, it's usually not enough because there is a lot of empty space in between. So they always coordinate and work in the fleet to, I don't know, pick up the pallet or bring it back to the staging area. And then somebody needs to tell the robots what to do. This layer is called warehouse execution layer. Basically, this is Jira for robots, because we know nothing happens in company if there is no ticket for it. So warehouse execution is basically ticketing system, task management for them. So when it comes to testing, what I learned, okay, we have two types of components we actually have to test. First type is, for me, a little bit less creative type of work, which is things we buy. And we expect that things we buy are good enough. So we use more quality control procedures and some incoming inspections, mostly like checklists, just to check if what we bought from the vendor is basically good enough quality as we wanted. So that part on the side. And there are in-house built components. And this is where the story became a bit more interesting for me. Because, hey, finally, a part of my work where I can try to apply exploratory testing. And I learned that's not so common when it comes to testing embedded systems. And we weren't so aiming towards this kind of techniques. And I noticed that the need for including more systems thinking and exploratory testing, while I was on my first week in the company, the team showed me around. And I was walking around our beautiful test hall. It was basically a warehouse we used for testing, where our office was. And I noticed this čistač grešaka. It's a piece of wood on a sophisticated equipment. And I asked, what's that? Why do we need it? And they explained me, yeah, we need it because we have a flaw in the first generation of our robot. It's a kind of design flaw. When we designed this particular piece of hardware, we just didn't think enough about the rest of the environment. So when the robot actually went to his parking spot, like the stand where it needs to rest, you couldn't access the reset button. And in case of some issues, like bugs happen, we had to reset it, using this button, because software was broken and we couldn't reset it using our software. And this little piece of wood was the only way to reset it, not to get hurt and squeeze your fingers. So I learned, we should do more exploratory testing and look further than just one component. So yay, finally something I can use from software here. Moving on. When it comes to software specifics, Remember, we are startups, and there are many, many layers you can test at. But we had to make some decisions. So most of our testing was focused on unit level, which is practically very similar to my past experiences, and also like integration level tests. That's not so interesting. What was new and interesting for me is system level tests. We figured that, okay, we don't have enough resources, so we need to invest more into system level rather than just deal with one particular component. And when it comes to system level tests, we did them in two ways. We used simulation, and we used the real environment. That's the fun part, the vehicles. But first, let's dig deeper into simulation. What is simulation? Have you played Sims? Yay, me too. I love playing Sims. It's basically for the ones who didn't play, who are not as old as I am. Basically, it's a game when you build your own character, and then you can put it in the house, and hopefully it lives long enough and has a happy life. So similar thing we do with simulation. It's the key ingredient. It's the bread and butter of embedded systems, basically. And we used open source software called Gazebo to simulate the populations of robots and how they operate in the complex environments. And there are many, many different things and layers in simulation, especially in Gazebo. But I like I like to mention just world files and models. World files are basically like environment you put your robot, and the models are different things that we use to operate with robot with. And in simulation, there's a catch. It doesn't come just out of the box. You need to develop it. So you need to invest a lot of money and people. You need to have people who will develop your simulation. And when it comes to development of the simulation, testability really matters, because on this picture is the example where testability wasn't as good, because this pallet should be on the forks, not flying around. So those are things that created a lot of friction when it comes to testing the robots in the simulated environment. And then achieving this good models, it's hard work. It takes a long time. So we always need to collaborate closely with our colleagues in development to get better models, and also to get faster simulation. This is the real-time factor. That's the name for how fast is our simulation. Because I don't want to wait for 3 hours for a robot just to do a task that will last for an hour and a half. So I at least want to have it like 1 by 1 or something, like being fast. And when it comes to simulation, remember, we were a startup, so we had to make choices. So we understood that we can simulate basic maneuvers. We can simulate stuff like, hey, I will give you a JIRA ticket, an assignment, and you will complete this assignment. And we could also to train the models using simulation, so the robot can recognize new type of a pallet much better, or other stuff that are going around in the warehouse. And my favorite part when it comes to simulation is validating the business case. What do I mean by that? So when robot needs to work somewhere in somebody else's customer's warehouse, and in order to understand if this is feasible, if we can operate in this warehouse, we need to basically copy their environment, and then we simulate all of the operation, and then we actually can make a decision, like strategic decision, if we are going to talk and negotiate with this customer. Because this process like takes a lot of time and money. So we will not even approach the customer if we didn't simulate their environment and understand if we can even work there. So this is, I find, very valuable because in this is what we build in testing, and we provided pretty valuable information to our management to make a decision if we are going or we are not going there. So that's my favorite way we used simulators. What can be tested, but cautiously. When I say cautiously, I didn't want to say if you have enough money, but basically that means if you have enough money. Of course, you can automate and simulate like safety functions, some semantics and physics. It can be done, but it's very expensive. Remember, we were a startup. So those things were things we just decided, okay, we will not deal with that at this point. We will more focus on the real vehicle when it comes to safety, semantics, and physics. So that's why I'm saying like cautiously. Even nowadays, when I move to a company that it's not a startup, we also simulate those things. But in startups, you don't have money for everything. Okay. Testing the real beast. Remember, I mentioned we can do a lot of testing on the real vehicles. And I find this very intimidating because this is me and this is the vehicle. And you see the difference in its size. And this beast basically has 4.5 tons. They can be smaller, of course, but this is the version we actually used. We had it in our test hall, and this is the vehicle we had to deal with it. And the time spent on this thing is expensive. It costs money. So a vehicle that's just standing and doing nothing doesn't make any sense. So it's not worthwhile. So we always had to be mindful about the opportunity costs and what are we doing with the vehicle. Because time spent on particular tests is time not spent on something else, and we just had limited resources. That's why I always like to be mindful about things like that, because you, as a tester, you are the part of this environment as well. So you need to come prepared, and you need to be mindful what are you doing, and especially with safety functions, and because safety comes first. And I need to have this vest, but this vest will not save me probably. It's just like I need to be bright colored, but also like shoes, and you need to know where you can go or not go. Those things really matter when you are testing something on autonomous vehicle, not like this vehicle moves itself. So that's dangerous part. And this preparation is the key, because I want to come prepared. I don't want to waste company's money and nobody's time just to have this vehicle sitting and not doing anything. So those 3 things were like really, really important and different when it comes to software, because in software we could always like revert things, put a new version, and here it's not so easy. I mentioned unpredictable things. Well, we had some situations where we learned how, okay, it's not enough to know your testing charters, your mission for today. You also need to be aware of the whole environment. For example, once we tested everything, we prepared and commissioned the whole fleet of our robots, and we were really ready for the production at the customer site. We were testing it for some time there. And one day, like, everything just stopped working. Like, we couldn't, like, our robots couldn't communicate with each other. They lost communication, basically. And we figured, okay, it's Wi-Fi or something with the network. Based on logs, Like we checked logs, we spent days. And we didn't figure it out until we went there, like, okay, sit in a car, go there and see what's going on. And you know what happened? The customer changed where the Wi-Fi is, because we put Wi-Fi boosters in the environment, and they were like this tall or like on the higher level. But they, for some reason, in one corridor, they put them on lower levels. And we just couldn't, there was no network in that area. And we wouldn't figure it out based on just looking at logs or anything. We just had to go there and, you changed it. So things like that can hurt you. Even the light can be a problem. Like we had a situation where we were testing and everything was working well. Like we were so happy with our system test that day until like 6:30 p.m. And every day, robot just went on the familiar place to pick up the same pallet, but it stopped. It couldn't recognize the pallet at all. Just stopped. And we couldn't figure it out, what was happening, until a colleague realized, hey, there is a window, and the sunbeam was like pointing directly to the camera. And since, you know, in warehouses, there are like lower light conditions, so this is something that comes first to your mind. And this sunbeam just like completely destroyed the system. Of course, we fixed it the next day. We adjusted the camera vision because it was also our in-house product, so we could do whatever we want with it. But still, like days of like having bad results in the same time, which was interesting. Also, they're like slippery floors, ramps. Robot can just forget where it's positioned because it can slip, and then it loses the position. It's just moved. So it can be very hurtful because if the robot thinks it's in one place and it's not on that place, it can hit the wall, it can hit some expensive parts of the customer's warehouse, which is something we really, really don't want to do. So all of these things matter. And believe me, toilet paper matters, because that was the hardest problem we had. Yeah, you cannot believe. We had different types of load, and toilet paper is very specific because it can do this. It's very heavy, but still so light. So we had a huge issue because we couldn't just buy a couple of thousand of, the one pallet of toilet paper costed like $3,000. And that wasn't something like I could just sell to my management, and we also needed to find this particular brand called AngelSoft. Thank you, AngelSoft. We solved it finding another ways, but yeah, knowing what your load is also very important when it comes to testing autonomous forklifts. Automation. Yeah, I was expecting nothing because I had no idea what can we automate, what cannot. In software, it's pretty much like you can do everything, but should you do everything? That's the question. And same thing here. So what we also had to make choices. We decided, okay, since log analysis bothers us a lot, because all of the logs were inside of the vehicle, inside of the robot's operating system. And after each test session, it was really cumbersome to upload them, and then you have to wait. The signal is really bad in the warehouse. So we developed helpful scripts that will automatically ship the logs, and we don't have to care about. That was very useful thing to automate. And also like some simple use case, simple things like, hey, are our components up and running? Because we figured that sometimes it happened that we came to the site, we want to work on the vehicle, we turn it on, we set our stack of components, you know, all of those fleet localization I was mentioning before, and they are not up and running, or they don't communicate with each other properly. So this is something we really wanted to automate because it was worthwhile. And also like some verification of those task completion stuff. Those are like cool things to just simulate and just test the happy path, at least. What we decided we won't do, not because it cannot be done, again, word caution, that means we had no resources, or we decided to spend them elsewhere. Like, if you have a company that has a lot of resources, of course, you will automate like a lot of safety functions because you won't see how different components are behaving under the hood. But this is not something we could go because we were a startup. Same thing with sensors and like physics. We just decided, okay, let's not go down that road, not yet. And last but not the least, like out of all of this story and experience I had, that was my first experience when I started with embedded systems. I noticed a few things that I want to share with you just as like, maybe it will motivate somebody to try, to dare like go into different industries than just software, because in embedded, you have a lot of software. And those new industries are really like a green field for new practices. Because like exploratory testing is still something I don't think we do enough inside of embedded systems. So I'm happy I kind of dared to go into that direction because, yeah, I just like to try those different approaches in new industries, at least for me. And nowadays, I think it's becoming more and more because more and more companies are playing with some sort of robotics, some sort of embedded systems, and there is always like some piece of software. So our work, if we are coming from software background, will be relevant in this industry. So don't be afraid and dare to try, as I said. Köszönöm.
Thank you very much, Irja.
Yeah. Good timing this year.
Oh, yeah. I know. We have like 2 minutes for questions, so I would like to ask for, how did you get information about the warehouses of possible clients?
Oh, I mean, talking to customer and asking them to give the information we need to even see if it's feasible. So usually somebody goes there, approaches them. Of course, that's not so easy. Arranges a meeting, and then you hope that you will get blueprint of their warehouse. Usually they are willing to give you that things. And
an interesting practical question. Did you go to some warehouse to drive the real forklift as a training?
You have to, if you want to work in this industry as a tester. For example, I have to now go to forklift driver training soon.
Wow.
Because I'm not allowed in this company. I work for another company now, and I'm not allowed.
So you need to make the license for forklifters.
Yeah. So I have a like secondary job opportunity if I fail with testing completely.
And last question, you mentioned that safety is important, but also something you had to defer because of resource constraints. How did you make sure the robots were safe?
We tested it on the vehicle.
Okay.
Yeah, we just didn't have money to automate those things, so we used we went in the warehouse and then we tested different situations and make our remarks.
Okay.
It was good enough for that stage of the company. It's not for ISO certification enough.
Thank you very much. If you have more questions, Irja is here with us until the end of the day. So another round of applause to our presenter, Irja Straus.
Thank you.